Ladies and gentlemen, welcome to the Intelligent Data Center session. This session will focus on Huawei's intelligent data center that offers flexible architecture and innovative technology. Thanks to more than 30 years of expertise in the ICT field, Huawei offers services that cover the entire data center process, ranging from network construction to O&M. At Huawei, we build intelligent, efficient, and green data centers that drive industry digital transformation. Let's first welcome Mr. Zhang Haiping, Director of the Product Portfolio Solutions Sales Department, to discuss Huawei's next-generation data center that will boost industry digital transformation.
Good afternoon, everyone. My name is Peter, and I'm the Director of the Product Portfolio Solutions Sales Department of Huawei Enterprise Business Group. Today, I would like to introduce Huawei's next-generation data center solution that enable intelligent upgrades across the industries. But first, let's look at recent changes in the digital industry. We are now in the fourth industrial revolution, where AI, IoT, 5G, bioengineering, and other intelligence technologies are changing our lives. They are driving sustainable development of society, economic growth, smart city construction, industry upgrade, and improve customers' experience. Intelligence is the key in the fourth industrial revolution, accelerating the digital transformation of society and the major economics and promoting the digital economy. As more industries deepen their digital transformation, there is an explosion in massive data, such as the video and the images. For example, a self-driving car can generate up to 60 terabytes of data center per day. And this data need to be stored for at least 30 years. All industry-leading gene sequencing device can generate up to 6 terabytes of data every day. And this data need to be stored permanently. A smart factory generates about 1 petabyte of data per day. In addition, intelligent oil and gas exploration is going from 2D to 3D, producing 10 times more data. Huawei GRV predicts that in 2025, the world will have generated 180 zettabytes of new data, a 20-fold increase over 10 years. Clearly, going digital produces more and more data, which become the core assets of enterprise. What do we mean by that? We all know that energy resources, such as the oil, the gas, drive the industrial economy. Likewise, data resources promote the digital economy. Data is now even becoming more valuable than oil. Data-driven innovation is gaining power in various fields, such as the economy, society, and R&D, and is a focus of many industries. This is why data is considered the fourth production factor following land, labor, technology, and capital. Data will never generate value by itself. However, with the intelligent technology, we can get unlimited wisdom from data. For example, AI can select only useful information from massive data volumes. It can then provide more efficient decision-making, suggestion, and smart behavior guidance. Clearly, the business value is huge. Data also improve operational efficiency, the quality of life, and the government administration. It also expands the scope of human knowledge. More and more enterprises agree that applying intelligent technology is the next stage of digital transformation. Deepened digital transformation relies on the intelligent to promote decision-making. reshape business model and ecosystems, and redefine customer experience. So the next stage of the digital transformation is an intelligent upgrade. The question is, how can we achieve intelligent upgrade of enterprise to tap into the real value of data? The answer lies in a powerful digital infrastructure. And the key to build such an infrastructure is the data center. First, the data center is the center for storing and processing the data. Huawei has predicted that the proportion of data stored in data center will increase from 53% to 92% in the next few years. Secondly, the AI training needs computing power. So data centers that deliver massive computing power become the AI training center. In other words, applying AI relies on the data centers, which decide how smart enterprises are. The data center is already the strategic factors for the intelligent upgrade of enterprises, and is the brain for the enterprise decision making. My next question is, what kind of the data center can better enable intelligent upgrade of the enterprises? As the digital production service moves to the cloud, more data need to be stored. The higher computing power is required, and more energy is consumed in the data center. This brings four major challenges to the data center. Firstly, computing power is insufficient. The AI performance relies on the powerful computing. However, computing power is becoming more costly and insufficient. As a result, just 10% of data is processed in data centers. So we need to focus on how to build a sufficient computing power for the digital economy. Data access is the second challenge. If we look at the data generated worldwide, the cost of the data storage is still higher. Currently, less than 2% of data is finally stored, and a lot of low-value data is discarded. Due to the poor storage performance, even some higher value data that is stored cannot be fully utilized. After digital production services go to the cloud, this requires high network reliability. The threats such as the natural disaster and the cyber attacks are everywhere. To overcome those threats, the data center needs to properly implement disaster recovery, which we call DR. So the third challenge is, what kind of DR center can ensure the zero data loss and avoid service interruption? The final challenge is higher power consumption of data center. If we look long term, the power consumption of data center requires more than 50% of the total cost of ownership. Also, data center is getting large. Globally, data center account for 50% of the power consumption of the entire digital ecosystems. So achieving the net zero carbon emission requires data center to consume less power. So building a green data center is of vital importance. Huawei has made many efforts to overcome those four challenges. For example, by leveraging expertise in full-stack products, we carry out joint innovation across the products and launch the next generation data center architecture. If we consider the current data center as the brain for the enterprise decision making, our next generation data center is a super brain for intelligent upgrade of the industries. Huawei's next generation data center solution have several highlights. First, it can provide lossless computing power to boost the digital world. Second, its all-flash storage fully unleashes value of data. Third, it delivers active reliability, ensure always-on services. Finally, it requires less power to helping our customer to achieve net zero carbon emission. Now, let's take a look at how Huawei achieves this through cross-product joint innovation. Computing power is the engine of the digital world. To obtain more computing power, we either use higher performance servers or add more servers. However, adding more servers will not always increase computing power. This is because more servers may cause network congestion and packet loss, which reduce the computing power. The test result shows that the computing power is reduced by 50% if the packet loss rate is just 0.2%. The more clusters lead to more packet loss, limiting the computing power. To resolve these issues, Huawei provides higher performance fusion server and the industry's only intelligent lossless data center switches. We call it Cloud Engine. Data is valuable only when it flows, and the storage performance affects how efficiently the data flow. In 2020, Huawei broke through the upper limit of storage performance once again. Huawei's next generation Ocean Store Dorado all-flash storage achieved 20 million RPS. How can Huawei develop such advanced devices? The answer is twofold. First, Huawei has been committed to all-flash for many years. Second, Huawei enables connectivity between the storage. System and front-end application servers. In addition, in the traditional storage systems, dedicated fiber channel is used for the connectivity. This delivers poor storage performance due to the limited bandwidth. To overcome this, Huawei used NVMe-based Rocky SAM. This technology used ultra-broadband Ethernet to fully unleash all-flash performance. This helps to reduce the end-to-end latency to less than 50 microseconds, the lowest in the industry. Data centers now carry many production services, such as the finance services. These services require zero packet loss and zero service interruption. The traditional data centers cannot meet these requirements as they perform active standby switchover upon faults. Huawei overcomes this by integration storage, switching, and WDM technology. In this way, the end-to-end latency is less than 1 millisecond, and the active service transmission reaches 70 kilometers to ensure 24/7 always-on services. Additionally, intra-city active traffic keeps increasing with the service growth. Traditionally, 8 GE or 16 GE fiber channel connectivity is used, which is waste a lot of optical fiber. So Huawei replaced the traditional fiber channel network with the 100 GE Ethernet to reduce the link data by 90%. This helped achieve lossless Ethernet transmission over long distance. Finally, let's look at Huawei's latest innovation in the energy saving and emission reduction for data centers. The IT devices, such as the computing, the storage, the network devices, account for more than 50% of the total power consumption of the data center. However, we cannot stop IT devices from the consuming power. So Huawei integrated many energy-saving technology into the IT devices, developed and designed to avoid unnecessary waste. These technologies include computing hibernation, system hibernation, and dynamic power management. The remaining 50% of power consumption in data center is caused by cooling, heat dissipation, and power supply. This is also called PUE. Huawei used iCooling technology to perform end-to-end energy efficiency management at the system level. reducing the PUE by 5 to 8% to less than 1.2. Now, let's look at the typical data center with the 100 cabinets. With the eye-cooling technology, about 4.54 million kilowatt hours can be saved each year. This is equivalent to planting 145,000 trees. This takes us closer to the building across a lower carbon intelligent digital world and achieve net zero carbon emission. Lossless computing, all-flash storage, and intelligent energy saving are the highlights of Huawei next-generation data center architecture. Thanks to cross-product joint innovation, this architecture comprehensively addresses the 4 challenges faced by data center in the digital economy. Build the super brain for the intelligent upgrade across the industry, and fully unleash the data center potential. In the next stage, I will invite my colleagues to introduce the detailed solution to you. Thank you.
Thanks, Mr. Zhang, for your insightful thoughts on how the next generation data center will support digital transformation across industries. Next, let's look at the key components needed to build a future-proof data center. Computing is one of the most important features for data centers. Now let's welcome Mr. Tang Qiming, Director of Huawei Computing Product Line. He will explore the concept of unlocking efficient computing power for data centers.
Hello everyone, I'm Tap from the Computing Product Line of Huawei. Today, I would like to share with you how to provide the more efficient computing power for data centers. According to the IDC report, the digital economy is the engine of the GDP growth. What does it mean? Well, the economy based on the computing technology is overtaking all others. Most commerce is being digitally delivered or enhanced, including the product, service, and experience. All enterprises need to process data, and digital enterprises use data centers to store, communicate, and transfer data without latency. This also uses data centers to solve energy uses, performance, and confidential data protection issues. Greater computing power in these data centers enable more rapid collection of larger diverse data sets, provide the faster performance of intelligence and big data analytics, and delivers the flexibility and efficiency needed to accelerate the digital economy. Computing power is therefore an accelerator of the digital economy. Huawei GIV 2025 predicts that the world will have generated 180 ZB of new data, or 18 times more than in 2018. 80% of this data will be unstructured, requiring a higher performance computing and storage. Let me show you some examples. Huawei's internal IT system consists of more than 1,290 application modules. These modules generate 2 types of data, OLTP and OLAP. The volume of the transactional data is about 10 PB, which supports companies' main business transaction flows for digital transformation. The volume of the analytical data is about 40 PB and grows by 1 PB per month. Another example is the city of Shenzhen that has deployed over 2 million cameras. These cameras generate 80 PB of data each day, which is stored for 30 days or even longer. These cases show that there's a lot of data being generated out there, and its volume will never stop growing. However, the statistics tell us that we use only about 10% of our data and store less than 2%. This means that we have yet to tap into the real value of the data. But to maximize it, we need to grow our computing power. So the question is, how can we improve the computing power? The answer is twofold. First, we need to improve the performance of a single server, and then we need to improve the deployment density of data centers. This means that to increase the computing power, we need to improve the computing density. However, traditional data center will face many challenges due to the higher computing density. Firstly, there is a bottleneck in terms of computing power. Server performance relies heavily on the CPUs and fail to meet different computing workloads. The second challenge is inefficient operation and management. Traditional data center relies on manual maintenance, leading to the low OM efficiency. High cost represent the third challenge. L1 and L2 are lack of linkage in data centers, leading to the high power consumption and cost. To address this challenge, we will upgrade traditional data centers, applying 3 solutions to make them smarter. First, equip data center with intelligent server that provide efficient computing power for different workloads. Second, improve the deployment density to build high-density data center clusters. Third, link L1 and L2 to achieve a fully intelligent data center. Now, let me delve into the details about these solutions. As I mentioned, to handle the gross computing power requirement, we need to improve the single server performance and the deployment density of data centers. Huawei believes that we need to address the Intel system to improve a single server performance, instead of focusing only on the processor alone. Huawei endeavors to improve the performance throughout the entire process, ranging from device boot to efficient operation. In terms of CPUs, we keep pace with Intel by equipping our next-generation servers with the latest Intel processors. For system boot, Huawei adopted innovative boot speed-up storage technology, BEAST, to improve boot speed by 3 times. In terms of network performance, the intelligent NICs in 200 and in 300 free up to 15% of processor resources by offloading the network protocols. And as for heterogeneous acceleration, we have developed Atlas 300 to integrate intelligent capabilities into our general-purpose servers. Together, this approach maximizes the performance of our Fusion Server Pro series servers. To improve the deployment density of data centers, Huawei has launched the Fusion Pod Rack Scale Server. It is a brand new product that redefines the heat dissipation and power supply. In addition, it is the only product in the industry that supports blend-made connectors for 3 types of cables: power, liquid cooling, and Ethernet cables. Fusion Pod is easy to deploy and maintain, and features high-density computing and energy efficiency. Therefore, it is ideal for large-scale scenarios, such as HPC. Fusion Pod adopts integrated liquid cooling technology. This can dissipate 80% of heat using liquid cooling and 20% of heat using air-to-liquid heat exchange. Fusion Pod implements full liquid cooling for the entire cabinet. With this technology, we do not need to install all the air conditioners in our data centers, reducing the PUE to 1.10. Compared with the air cooling system, our design improved the power by 4 times, so as the deployment of density of a single cabinet by 4 times. In summary, this product is ideal for building higher density data center clusters. As the number of servers in data centers continues to grow, OM challenges also increase. Customers look into improve their OM efficiency and reduce OM cost. In response, Huawei has introduced 5 intelligent technologies to make OM more efficient and cost-effective throughout the network lifecycle. For example, our intelligent maintenance technology could help predicting a hard disk fault 7 to 30 days before it occurs, preventing servers breakdown and other network accidents. In terms of the saving energy, we have introduced energy-saving technology for devices, cabinets, and data centers. For devices, we offer dynamic energy management technology, which detects the operation status of the upper layer servers and adjust the power consumption of server accordingly. This helps reduce the power consumption by 15%. Every year, when Intel releases their latest processor, Huawei launches a next-generation server running on the latest Intel technology. This strategic partnership has lasted for 20 years and will continue in the future. Currently, our mainstream servers are the Fusion Server Pro V5 series. All the V5 series servers are equipped by the two cutting-edge Intel technology, the latest Cascade Lake refresh processor. In addition, all V5 series servers will evolve to next generation V6. In June 2020, Huawei released the Fusion Server Pro 2488 HV6. This is a full-socket server running on the third generation Intel Copper Lake processor. In April this year, we will launch more V6 series servers. For years, Huawei has worked in close partnership with many vendors, such as SAP and VMware. To date, Huawei's new Fusion Server product has been certified for the SAP HANA solutions. Huawei has also completed the related certification for the VMware vSAN solutions. In this way, we can provide our customers with all-flash storage servers and hybrid storage servers. Huawei's computing product and solutions are highly recognized by top customers across the industry worldwide and has been chosen by 211 companies on the Fortune 500. In particular, this product and solutions has attracted 3 of the world's top 5 banks and 4 of the world's top 5 automobile manufacturers. Huawei also serves top internet and energy enterprise worldwide. Adhering to win-win cooperation, Huawei joins hands with industry chains and partners to provide the best-in-class service across the industries and drive the digital economy with higher and more efficient computing power. That's all my presentation. Thanks for your time.
Thank you, Mr. Tang, for your detailed thoughts. Rapidly growing services and data volumes brought by industry digital transformation will impact the storage system. The question is, how can enterprises build a green, reliable, and intelligent storage system to release the real value of data? To answer this question, Ms. Amy Liang, Vice President of Enterprise Data Storage Technical Sales Department, will share her thoughts on the topic, moving towards an all-flash-powered data center. Let's welcome Ms. Liang.
Ladies and gentlemen, I'm Amy Liang. Today, it's my great honor to share with you of the next topic, moving towards an all-flash-powered data center. As we can easily judge, the world is fast diving into a fully digitalized era. In the past 10 years, the whole data amount has increased several times. And with the explosive growth of internet traffic, in next 5 years, the amount of data to be stored will increase from 32 zettabyte to 180 zettabyte by the year 2025, among which the unstructured data will account for more than 80%. Like in the agricultural economy age, the land and the labor were the primary production factors. In the industrial economy age, capital and technology became important factors of production. Now, with the advent of the digital economy, data is a core means of production. Take digital interconnected factories as an example. The data volume is easily increased to PB level, and to develop one model of self-driving car, at least 64 terabytes daily training data will be generated per day. The data explosion drives the maturity of the data volume chain and further drives enterprise decision-making and innovation to generate digital dividends. Thus, we need powerful digital infrastructure to capitalize on data during this transformation. Most of the data infrastructure are installed in data centers, like servers for computing, switches for data exchange, and storage for data reservation. In light of explosive data growth, diverse data types, and the ever-increasing importance of it, data centers face the following challenges. First, the service pressure becomes higher and higher. The digital transformation of enterprises drives huge amounts of offline services to go online, and innovative services are emerging one after another. Online and diversified services result in more than 10 times of peak loads, which requires high reliability. This is amplified by the finance sector, especially due to the e-commerce and mobile payment. During peak hours in China's Double 11 shopping festival, the transactions per second of a large bank increases from 3,000 to 30,000. Second, with the data volume and application increase, data centers are getting larger, and the total amount of small and edge data center grows. Data centers have become a major power consumer. Currently, the total global power consumption of data centers costs around 2 to 3% of the annual world power consumption. And the power consumption will reach 42% of the total ICT consumption by 2025. High energy consumption results in high electricity costs. In fact, electricity costs account for 60% of the total TCO of a data center during its 10-year life cycle. Another consequence to consider is the high carbon emissions. The global carbon emissions of data centers are equivalent to those of the aviation industry and account for 60% of the total energy consumed by the digital ecosystem. According to the United Nations Environment Program, global emissions must fall by 7.6% per year for the next decade to meet the 1.5 degrees centigrade goal. The European Union is committed to achieve zero carbon emission by 2015. There is still a long way to go for data centers to save energy and reduce emissions. Third, as data becomes more and more important, data center shutdown becomes unacceptable. Statistics show that nearly 1 million enterprises go bankrupt every year due to data loss. And the loss caused by downtime in the financial industry reaches up to 6.48 million per hour. 4. There are also other costs to consider. A data center with 1,000 racks usually has over 100 types of devices, and information about dumb devices is not transparent, which increases the difficulty in fault location and related service response. Due to a large number of vendors and interface, the training cost of operation and maintenance personnel are high. As a result, 61% of data centers lack qualified O&M personnel. By 2025, the amount of data maintained per capita will increase fivefold, which further increases the difficulty of O&M and labor costs. All the challenges will require an upgrade on data center technology, not only of the media, but also the integration of data center resources and reconstruction of the architecture in order to meet diverse future service requirements. Specifically, the all-flash data center solution covers all-flash upgrade for the whole IT infrastructure, flash-based servers, NVMe native all-IP data center network, all-scenario all-flash storage, and full lifecycle intelligent O&M for multiple data workloads. For storage ledger, the upgrade has 3 key characteristics: all-scenario flash, full series high-end quality, and all-scenario data protection. It helps build a greener data center with higher efficiency and availability, more intelligent O&M, lower TCO, and zero network bottleneck. All scenario flash have 2 meanings. The first is that Diverse types of data are willing to be stored in flash media-based system. Not only the data from enterprise mission-critical applications, but also those data from edge, HPC, big data, and other systems. The second is that from primary storage to secondary storage, like backup appliance, HDDs should be replaced by SSDs to enhance the performance while reduce the cost and power consumption. All-scenario flash delivers two benefits: cost reduction and efficiency improvement. Offering the same capacity, SSDs reduce power consumption by 70% and space by 50% than SAS HDDs. This slashes the TCO of data centers and helps them to go carbon neutral. In terms of procurement costs, IDC statistics show the unit price of SSD is now lower than SAS HDD by introduction of deduplication and compression functions in storage system. So we already see the SSD shipment proportions increases year on year, and replacing HDDs has become an inevitable trend in primary storage scenarios. And from 2020 to the next 5 years, along with the usage of several types of new low-cost media like QLC-NAT, the secondary storage will also change to flash-based. Here we got an example. A bank changed their total 10 cabinets of storage to 4 cabinets of flash storage. The performance increased by 150%, saves 60% of space and power, and 50% of manpower, since all the technology are similar from no big difference between systems. Well, all-scenario flash transformation also requires high-end quality for both high-end storage and mid-range storage. Take banking industry service as an example. Traditional core services include payment and transfer, daily settlement and monthly settlement, card issuing, and wealth management. Such data requires over 6 nines availability, million-level IOPS at a latency of sub-millisecond per device, as well as both high scale-out and scale-up capabilities. With the advent of the Bank 4.0 era, the friction-free model developed intermediate business and intelligent services blur the boundaries between core and non-core services. Fast mobile payment and ubiquitous financial services drive higher service processing requirements. Take a typical medium-sized bank as an example. The bank requires 24/7 service continuity. It has seen a 10-fold increase in transaction frequency and a 40-fold increase in daily data volume, from 50 gigabyte to 2,000 gigabyte. So here's the conclusion. Facing the uncertain, fast-changing future, even mid-range storage needs to offer high-end quality to address higher service demands. Now, let's look at the comprehensive data protection solution. It has 3 aspects: disaster recovery mechanism to create an active or passive full copy for the source data, backup mechanism to create several time-based copies for the source data, and archive mechanism to move source data to a longer retention media and make copies to protect it. In short, when building an all-flash data center, those 3 mechanisms should be considered. There's a challenge leads to cost efficiency, faster solution. During the last decades, data is more and more used for mining and big data analysis. The life cycle of data stay in the main storage system is prolonged, and the volume of data retention and protection is enlarged according to the demand. But the time window and budget for data protection didn't change or become even less. by introducing local active-passive function to replication to the cloud. The system availability improved. By adding flash disk into backup storage and improve the data reduction ratio, the huge amount of data is able to be fast backup within a certain time window at low cost. Traditionally, in the data center, fiber channel network is the last specialized network used dedicated for connection between server and storage. Now, all-scenario flash is driving the storage media interface transform from SCAS to NVMe, which calls for a faster, reliable network. Currently, normal fiber channel network speed is 32 gigabit per second and 64 gigabit per second. Comparing with Rocking network 25G, 15G, 100G, it is serialistically much slower and not able to unleash the power of flash storage. That brings us to NVMe over Rocky storage network. NVMe over Rocky is an easy-to-manage model that uses IP network to provide 10 times higher throughput and lower latency than fiber channel. The NVMe over Rocky solution is the best solution for implementing an end-to-end NVMe storage network. An all-flash data center should have full lifecycle intelligent O&M capabilities. That is, automatical and intelligent capabilities are available in all phases of planning, provisioning, O&M, and optimization. Intelligence and big data technologies are key to improve data center management. In the planning phase, resources are preciously planned, and the focus has shifted from device upgrade to full lifecycle data management. In the provisioning phase, global resources are automatically provisioned. In the O&M phase, full-stack intelligent O&M is implemented to change reactive inspections to proactive discovery. In the optimization phase, agile configuration optimization and automatic resource prediction and change are implemented. The optimization is performed using intelligent algorithms instead of expert experience. Today, we are glad to bring you the Huawei all-flash powered data center solution, which is business-enabling, green, reliable, and intelligent. The solution consists of OceanStor all-flash storage series as primary storage, Ocean Protect series as data protection secondary storage, NVMe over Rocky storage network either from Huawei or other vendors, and DME full lifecycle intelligent O&M. Huawei OceanStor all-flash storage is very suitable for serving the core application systems in a wide range of industries like finance, carrier, medical care, and manufacturing. It delivers industry's highest 7 nines reliability. The storage tolerance failures of 7 out of 8 controllers and the failure of a single controller enclosure without service interruption. Moreover, SSDs yield at 5 years return rate of just 0.8%, which is 10 times lower than HDDs. When it comes to performance, the OceanStor all-flash storage delivers the industry record 21 million IOPS under typical frequent used I/O patterns. The performance with various features enabled has only less than 10% impaction. For example, when data reduction, garbage collection, read-seeks, and snapshots are enabled, the performance of our storage decreases by only about 10% and remains stable. In contrast, the industry average performance of other vendors' storage decreased by 40%. In terms of availability, The Ocean Store all-flash storage provides 100% data availability guarantee and flash-ever hardware subscription model to the customer to protect the customer's invest. Huawei Ocean Protect provides customers with all-scenario data protection. We provide a comprehensive solution that protects data throughout its lifecycle, from data generation, use, to destruction. The overall solution that includes disaster recovery and backup helps our customer achieve disaster recovery of production data, backup of critical enterprise data, and valuable data reuse. Huawei Storage provides various disaster recovery features, such as active-active, active-passive, and 3DC solutions, and uses Ocean Store BC Manager for unified, intelligent, and simplified disaster recovery scheduling and O&M management. In the backup scenario, we provide both centralized backup solution and all-in-one backup appliance to allow customers to collectively or separately deploy backup storage and media to meet different customer needs. We fully understand the main purpose of backup is to recover the data when needed. Our Ocean Protect backup appliance has the fastest speed among all the vendors. And we are working on helping the customer reuse the backup data directly from the backup appliance for like test and validation scenarios. As I mentioned in the previous slide, the trend of storage network now is changing from FC only to NVMe over Fabric. And IP-based storage network has big advantages on both speed and cost. However, the IP network often encounters packet loss. When SSDs are used in the IP network, the storage IOPS increases and the Ethernet network pressure grows, causing the packet loss rate and the network latency to surge. To address this issue, Huawei intelligent IP switches use an innovative lossless algorithm to dynamically adjust the threshold, greatly reduce packet loss and ensuring consistent low latency of the storage network. The all-IP NVMe over Rocky network reduced the average latency by 42% compared with the fiber channel network, achieving an end-to-end latency of less than 50 microseconds and 30% higher IOPS. Huawei introduces Data Management Engine, or DME, to ensure automated management throughout the data lifecycle. It automatically collects the running status of all devices to ensure end-to-end storage network awareness. It also predicts and warns about faults to help prevent disasters, and can intelligently analyze information to rapidly locate the root causes of faults. Last but not least, it provides expert suggestions to help users to optimize their systems and achieve end-to-end automated, trusted execution. It's time to choose a fully future-oriented, all-flash-based solution for your data center construction plan. Huawei in this industry is quite highly recognized. Not only garnered the Best of Show Award grand prize at Interop and was recommended as the leading position among global top 5 by DCIG, but has also been listed as a leader by Gartner for 5 years consecutively. We maintain strong growth in the global market, has been chosen by the most customers in China since 2018. We are now serving over 12,000 customers all around the world. Hope that we can have the chance to cooperate in this area. Thank you.
Thanks, Ms. Liang. High-performance computing underpins most industries and is becoming more and more important for decision makers. On top of this, a variety of technologies are using AI and high-performance data analytics. Against this backdrop, we invite Mr. Lü Dejian, Chief Expert in the mass data storage domain, to talk about how next-generation storage accelerates HPC evolution. Let's welcome Mr. Lü.
Hello, everyone. I'm Lü Dejian from Huawei Mass Data Storage Domain. As we all know, more and more HPC applications are using AI and big data technologies to improve efficiency. We know that data plays a critical role, whether AI, big data, or HPC. So storage is becoming more and more important in HPC. What role does storage play? I'd like to share some of my insights to answer this question. It's no secret that HPC is playing a critical role in our society. It has become an important driving force for social progress. For example, we can use HPC to accelerate drug screening and molecular analytics, greatly shortening the R&D period of new drugs. When it comes to automotive industry, HPC helps implement autonomous driving simulation by using data to simulate for diversified scenarios. This greatly reduces cost and time of development. Another example is from genome sequencing. It took 13 years to fully complete the whole genome sequencing at the beginning. But with the help of HPC, we have shortened the time to just 1 day. Remarkable, right? In weather forecast, with HPC, we have a strong feeling that the forecast accuracy is much better than what it was 10 years ago. In recent years, HPC has become even more closely integrated with big data and AI. Data is becoming more important to HPC. This has promoted the HPC industry to evolve from computing-intensive to data-intensive. Let's take a look at the HPC market growth rate on the right. It shows that the data-intensive HPC markets are growing much faster than traditional HPC. Now, let's look at 3 major challenges faced by the HPC industry. The first challenge arises from massive data generated by new technologies and emerging workloads. For example, an autonomous driving test vehicle can generate up to 60 terabytes of data every day. This data must be stored for at least 30 years. The most advanced sequencer can generate 6 terabytes of data each day, which need to be stored forever. In the oil and gas exploration industry, compared with 2 dimensions, 3 dimensions generate over 10 times more data. Ever-growing data volumes will bring big challenges to HPC infrastructure with higher TCO, such as procurement cost, data lifecycle management, rack space, and power consumption. The second challenge comes from hybrid workloads. For traditional applications, they often involve multiple processing phases. These phases usually have a different I/O behaviors. I'll take oil and gas exploration as an example. Seismic data processing requires high bandwidth, while seismic data interpretation needs high OPS. Generally, 2 different storage systems are required to host these 2 types of workloads. As for emerging application, they cause explosive growth in diversified computing, such as GPU, NPU, and FPGA. This further increases the challenges of diversified workloads. The diversity of data access method is another challenge. Let's take autonomous driving as an example. The development process involves multiple phases, such as data import, data pre-processing, model training, and simulation. There are diversified data access protocol interfaces being used in those phases, so time-consuming data migration cannot be avoided. But time is very important to the end-to-end development process. We heard a lot of complaints from our customers for this situation. To sum up, we believe that increased data analysis requirement in the HPC industry create 3 main challenges for storage. First, enterprises find more and more value in massive data. They are willing to store more data for a much longer period. This causes the data volume to grow from petabyte to exabyte level. Consequently, they need a storage system with higher scalability and lower TCO. Second, diversified computing leads to more complex workloads. This requires one storage system to support different types of workloads. Finally, HPDA requires efficient data access in multi-phases, so the same data can be accessed over different protocols without migration. Thanks to continuous investment in HPC, we have built a full-stack infrastructure solution. We focus on development of basic hardware platform, software platform, and professional services. By working with our industry partners, we offer a variety of professional solutions for customers across multi-industries. Storage is an important component for our full-stack HPC solution. With extensive know-how in storage, we aim to unlock HPC potential with extraordinary storage power for a variety of customers. In the past years, we have developed a storage product for different HPC scenarios, such as the OceanStor 9000 series for distributed file system, Fusion Storage for big data. The OceanStor Pacific series we are introducing today is the next generation high-performance storage. It can help customers address new challenges arising from the HPC evolution. It has 3 key features. The first is its high-density design, which increases the capacity and the performance densities to minimize the footprint and TCO. The second feature is that the storage is oriented to hybrid workload for higher performance in all scenarios. And the third is the multi-protocol interworking feature that supports the evolution from HPC to HPDA. Let's take a closer look at how we use these innovations in typical scenarios. First, in scientific research, such as genetic research, genome sequencing generates a huge amount of hot data, which requires extremely high storage performance. After sequencing is complete, cold data need to be carved to an economy storage. Our next generation storage, the OceanStor Pacific, can easily deliver a storage solution for these requirements with optimal TCO. First, compared with general-purpose hardware, the high-density hardware design can reduce cost by over 20%. The OceanStor Pacific 9950 is a high-density performance model. It can provide a bandwidth of 32 gigabytes per second per unit space, delivering excellent performance to deal with massive data. The OceanStor Pacific 9550 is a high-density capacity model. It provides 1.6 petabyte raw capacity in a 5-unit space, which is 2.7 times the capacity density of a traditional high-density server. Second, based on the configured policy, the data tiering feature efficiently and automatically migrates data between a high-density performance pool and a high-density capacity pool without manual interaction. Next, let's look at the oil and gas exploration scenario. As we know, seismic data processing requires high bandwidth, while seismic data interpretation requires high OPS. Traditionally, 2 storage systems need to be deployed to meet the requirement separately. To tackle bandwidth-intensive and OPS-intensive hybrid workloads, we launched OSINT-FS, which is the next-generation power file system delivering both high bandwidth and high OPS. First, OSINT-FS distributes metadata on multi-nodes to eliminate the distributed locking overhead. This can reduce the latency by 15%. Second, large and small IOs are separately processed to decrease resource contention. This can reduce the overall overhead by 60%. Third, the dynamic disk indexing technique prevents I/O amplification, reducing the latency about 30%. With these features, OSINT-FS enables one storage system to fully meet the needs of multiple phases. Finally, let's look at how manufacturing simulation benefits from multi-protocol interworking. In SPDA scenarios, such as autonomous driving development, there may be different data services to be used in phases of pipeline, such as file, object, and HDFS. Traditionally, these three services are separately provided by three storage, meaning data needs to be copied multiple times between devices, causing lots of wasting on time and resource. In contrast, the multi-protocol interworking capability of the OSINT Pacific allows one data copy to be shared with multiple protocols. And all data service interfaces are native. The native interface design achieves zero loss of semantics and performance. With the OSINT Pacific, we can shorten end-to-end simulation process, reduce the time to market our product. Now, let's review the three major HPC scenarios of the OSINT Pacific. In scientific research field, we are always trying to help our customers to reduce TCO. We use a high-density design to reduce both CapEx and OpEx of HPC environment. In oil and gas exploration field, the hybrid workload-oriented design enables one storage system to handle the data produced in multiple phases. It simplifies the management of HPC infrastructure. In manufacturing simulation field, the OSINT Pacific can provide file, HDFS, and object service interfaces in one storage. So no data migration is needed. We can shorten end-to-end simulation process, reduce the time to market a product. Huawei will continue to provide our customers most valuable storage solution and working with industry partners for faster and smooth evolution of HPC. That's all. Thank you.
Thank you, Mr. Liu. For those of you who want to achieve lossless computing in data centers in order to better support service development, we invite Mr. Zhang Lei, Director of Huawei Cloud Fabric Data Center Network Solution. He will explore the topic, Hyperconverged Data Center Networks 100% Unleashing Computing Power. Let's welcome Mr. Zhang.
Hello, everyone. Welcome to Huawei's Cloud Fabric Data Center Network Forum. First of all, I have some good news to share with you. This year, Huawei's Cloud Fabric will be upgraded from 2.0 version to 3.0 version, giving birth to a more advanced solution named Huawei's Cloud Fabric 3.0 Hyper-Converged Data Center Network Solution. This solution will maximize the computing power with new Ethernet. You may be wondering, what are the characters of this new solution and what benefit can it bring to us? Now, follow me to figure them out. Firstly, let us see what is the data center network. The data center network connects general computing, storage, and HPC network, and carries massive service from mobile app and website to big data and AI training. All data exchanged between servers is forwarded through the network. It's like a highway between cities. The data center network connects computing and storage server to support the IT architecture of the entire data center. Once the interconnection object and the architecture changed, the network needs to be adjusted accordingly. Such changes are always taking place in data center. The architecture, computing, and the storage transformation are driving the data center to evolve from the multiple protocol mode to the Ethernet mode. First of all, the IT architecture changed from the centralized to distributed, and large-scale node interconnection usually use Ethernet. Secondly, we know PCIe is replaced for computing units, regardless of CPUs or GPUs. It helps to break through the bus rate bottleneck. The Ethernet interconnection is used to provide higher computing power. In addition, the storage media are involved from HDD to SSDs. The performance is improved by 100 times. The traditional FC network provides only 32 Gbit per second bandwidth, which cannot meet the all-flash high throughput requirement. Therefore, the 400 GE Ethernet becomes the de facto standard of the next generation storage network. Of course, we also see that the evolution to Ethernet faced three challenges now. Firstly, it is well known that packet loss always occurs on the Ethernet. This has been not resolved for more than 40 years since the Ethernet birth. As the network scale increased, the packet loss rate increased exponentially. Secondly, in the intra-city active-active storage scenario, the actual latency of hundreds of microseconds caused by long-distance transmission. This makes it more difficult to achieve zero packet loss. In addition, the Ethernet lacks effective OEM method. We know in the cloudification trend, the network scale increased by 100 times. And there are millions of relationships between network objects such as port and policy. Therefore, network OEM cannot be performed manually. To address the three challenges, the next generation data center network must have three features. Firstly, the network must implement the lossless Ethernet and the convergence of computing and storage network. Thus, packet loss can be solved in the local and long-distance transmission. Secondly, the management layer must implement full lifecycle automation of deployment to ensure that the network quickly responds to requirements change and the services are quickly rolled out. In addition, the network-wide intelligent OEM must be implemented to ensure zero service interruption. Based on the preceding consideration, Huawei launched Cloud Fabric 3.0 hyperconvergent DCN solution. It consists of two components: the iMaster NCE, an intelligent network management and control system, and the Cloud Engine data center switches. We can see that this solution can provide full benefit. The Ethernet HPC network can ensure zero packet loss during local transmission and 100% release of computing power. The active-active Ethernet storage network can ensure zero packet loss during long-distance transmission and reduce the number of cross-DC links by 90%. And then, full lifecycle automation helps shorten service TTM by 90%. In addition, AI-based network-wired intelligent OAM can be implemented proactive prediction of 90% fault. In the HPC Ethernet scenario, we mentioned that the packet loss problem on Ethernet was lost for more than 40 years, but Huawei's solution can achieve zero packet loss and 100% throughput on the HPC network. It can double computing power. You may ask, why does the packet loss occur on the Ethernet? We know when multiple servers send a large number of packets to one server at the same time, and the number of packets exceed the processing capability of switches, packet loss occurs. In this case, data need to be retransmitted, which reduces the transmission efficiency. Experiments show that 0.1% packet loss causes 50% computing power loss. Over the past 40 years, Ethernet experts have tried many methods to solve this problem, but they have not found a perfect solution. Among these methods, flow control and back pressure are used to control the traffic transmission rate. However, the rough back pressure mechanism frequently stops the packet transmission. As a result, the throughput is extremely low. In addition, as the network application traffic becomes more and more complex, it is difficult to control traffic at the right time. To solve this problem, Huawei innovatively introduced artificial intelligence algorithm to network connections, used the intelligent lossless algorithm to replace expert experience. Through continuing training of millions real service samples of HPC and the storage scenario, and tens of millions of random samples, Huawei Intelligent Lossless Ethernet solution can implement real-time and precise traffic control to ensure zero packet loss in any traffic scenario. In this way, the computing power can be doubling when the server scale remains unchanged. In the storage scenario, we know that FC is widely used in the industry before the cross-DC active storage solution. But why is the Ethernet not used? The main reason is that the active storage requires zero packet loss. However, the traditional Ethernet flow control algorithm becomes invalid when the transmission distance exceeds 1 kilometer. Once traffic bursts occur, packet loss occurs. Huawei makes a breakthrough with the long-distance lossless DCI algorithm. This algorithm can make random traffic determined based on real-time network indicator and AI prediction status. In this way, the lossless Ethernet transmission within 75 kilometers is achieved. It can meet customers' requirements. The Huawei's Ethernet solution has been successful put into commercial use in financial industry. It improved the network bandwidth from 32G to 400G, achieving a 10-fold increase in the bandwidth. In addition, it improved the storage IOPS by 87%. To meet storage requirement, Huawei launched its brand new range of Cloud Engine data center storage network product, including Cloud Engine 68607 and Cloud Engine 88507 switches, as well as the same series of line cards for Cloud Engine 16800. Their product is ideal for building high-performance, low-latency, and high-reliable storage network for customers' storage service. From the perspective of entire service provisioning process, traditional service deployment is a semi-automatic process. In the planning, construction, maintenance, and optimization phase, only network configuration is automatic, and the other phase need to be manually performed. In the planning phase, all evaluations are performed manually. More than 10 indicators are reviewed by multi-person across departments, which always take several days. Similarly, the verification after the network change is also a complicated process. It usually takes 3 hours to verify the connectivity between all nodes on the entire network. This two-dimensional service mode becomes the bottleneck of service provisioning for network change. One service change always takes about 1 week. But how can we solve these issues? Huawei's solution creatively introduced 3D modeling. We know that 2D is a plane, like a photo, and 3D is a real world. It can carry more data and information. In the planning phase, we break down more than 400 factors that affect network design into 3 evaluation dimensions: resource, quality, and reliability. We used the multimodal method to implement automatic design and optimal recommendation of network solution. And in the maintenance phase, we digitized the network topology information and added to a 3D space with the device configuration and traffic information. In this way, network-wide reachability can be verified at one time. This technology can be used to implement second-level verification on a large-scale network with a large number of configurations. Based on these 2 features, we built intelligent capabilities for the entire process to implement second-level service provisioning. After resolving service deployment issues, let's focus the network OEM. From the centralized mode to the distributed mode, the decision scale increased by 100 or even thousands of times. There are more than 1,000 KPIs and 10,000 of configurations. The relationship between port, device, and link are very complex and cannot be defined. Besides, the network states change rapidly. Traffic changes suddenly in milliseconds. The DCN complexity is beyond the coverage of traditional method and individual wisdom. We say the data center network OEM require AI assistance. Huawei's solution introduced AI knowledge graph to network OEM. It can locate fault within 3 minutes and predict 90% of risks. But how can all this be achieved? Firstly, Huawei have accumulated a large number of knowledge assets and tens of millions of data samples based on 30 years of OEM experience. Through big data mining and modeling, the solution can identify association between network objects. The fault diffusion rules can be identified through AI training to spot 90% potential risk. And after I master NCE its deployment on the live network, it can perform incremental training based on online self-learning and live network data to proactively predict up to 97% risk. Based on the capabilities of AI knowledge graph, Huawei solution transform passive OEM to proactive OEM. It implements automatic closed loop from risk awareness to rectification and ensure the service always on. This shows the product panorama of Huawei's hyper-converged DCN solution. It includes the software product iMaster-NCE, as we mentioned before, which is an intelligent network management and control system. And it also includes an extensive range of Cloud Engine data center switches. We can provide GE to 400 GE data center switches, meeting various interconnection requirements of HPC, storage, and general computing server. Up to now, Huawei's DCN solutions have been deployed in data center of more than 12,000 customers around the world. It shared has ranked #1 in the Chinese market for 4 years. In addition, Huawei's 10 GE and 25 GE port shipment also have ranked #1 in the global market. The unmatched performance of Huawei's DCN solution has also been verified by many third-party analysis organizations. For example, Huawei is positioned as a leader for SDN by First. In addition, Huawei is listed in Gartner's Challenging Quadrant. And the Huawei's DCN solution and product have also won a lot of awards, such as First and Sullivan 2020 Global Technology Leadership Award and the Best of Show Award of Interrupt. They are also recognized as Gartner Peer Insight Customer Choice 3 consecutive times. That is all my today's sharing, and I'd like to sincerely thank our customers for your continued trust and support. Looking into the future, our conquest is the Year of the Star. We will continue to pursue higher network capabilities, maximize the computing power, and create great value for our customers. On the way forward, we are confident that we can overcome technical difficulty one after another, and we will make an unremitting effort to help customers and the society achieve digital transformation. Thank you.
Thank you, Mr. Zhang. Connectivity between data centers is essential regardless of whether data centers are centralized or distributed. The optical industry is hoping to advance DCI through cutting-edge technologies. Mr. Maxim Kushnarov, Director of Huawei Optical and Quantum Communications Laboratory, will introduce the topic Huawei DC Optics 2.0 Better DCI Evolution. This solution helps unlock the bandwidth potential of optical fibers using less space in equipment rooms and achieves AI-powered proactive O&M.
Hi, my name is Maxim Kushnarov, and I will talk to you today about Huawei's DC Optics 2.0 solution. The fourth industrial revolution featuring intelligent technology is coming. It will help build smart cities, improve consumer experiences, and promote the digital transformation of industries in a faster way. As a key engine for the fourth industrial revolution, intelligent technology will promote global advancement and development. Timeliness of data is critical to intelligent technology. Underlying conditions can change rapidly, so the latest data needs to be provided to the AI model to continue driving business value growth. Outdated data affects the value of the model, and it is important to keep the data online and flow smoothly in real time. Data centers are carriers of data and applications. Therefore, establishing real-time and smooth connections for data centers is the key. As digital transformation is running in a faster way, server security and agility requirements drive the transformation of data centers from large data centralization to 2 geographically dispersed parallel data centers, and then to 3 geographically dispersed parallel data centers. Some industries, like over-the-top providers, have widely used distributed architectures with multiple sites. As data is stored and accessed in a distributed manner, data traffic shifts from intra-data center to inter-data centers. With DC cloudification, the topology of data centers interconnection changes from links to networks. Therefore, it's time to focus on data center interconnects, DCI. According to the report, the bandwidth needs for all kinds of industries grow fast, such as finance, government, or OTT. Every 2 years, the traffic among the data centers is doubling. At the same time, the lease fee for bandwidth becomes a heavy burden for enterprises. As an example here, self-built DCI with 100 gigabits per second or higher capacity breaks even in less than a year. So self-built DCI is a new trend and necessity for enterprises. Traditional WDM DCI solutions are complex and hard to manage. We cannot accept the space leasing fee and fiber leasing fee increase with the same speed of bandwidth required. What's more, most enterprise data centers only have IT or IP engineers. They lack the experience in optical transmission. Complex and slow deployment delays the service rollout. A large number of losses are caused if fiber faults occur. The passive O&M mode hinders engineers. So the key points of self-built DCI should be less space, more bandwidth, and simple O&M. In order to help the enterprise to solve all these issues, as the optical industry leader, Huawei develops the DC optics solution. In 2020, we released the 1.0 version, which brought the high integration with 4.8 terabits per rack unit, ultra broadband with maximum of 48 terabits per second per fiber, and simplified operation and maintenance, which brings auto commissioning within 8 minutes. In 2021, the DC optics solution is comprehensively updated to version 2.0. With 6.4 terabits per rack unit higher integration design, it can bring 50% space savings to data centers. It achieves a maximum of 88 terabits per second per fiber capacity, bringing 40% more fiber lease saving. In the O&M part, DC optics has evolved from automation to intelligence, including fiber health prediction, co-bundling fiber cable detection, and accurate troubleshooting functionalities, so that IT and IP engineers can perform DCI in an easier way. As the key product of the solution, Huawei OpticTrans DC908 was the only award winner in Interop Tokyo 2020 and can revolutionize your data center interconnect. Traditional WDM devices are complex and occupy valuable space resources for storage and computing. Huawei OpticTrans DC908 simplifies WDM devices, similarly shifting from a mainframe to a blade server, and it puts electrical and optical layers in one box with a highly integrated board design, achieving more than 50% space saving. In 2021, thanks to the application of 800G technology, DC908 reaches 6.4 terabits per rack unit with 1.6 terabit per slot capacity, which brings 33% additional space savings to data centers. Huawei is continuously unlocking the bandwidth potential of fiber. In the version 1.0, based on 400G and 600G technology with 6 terahertz super C-band, the DC optics solution reaches a maximum of 48 terabits per second per fiber. In the version 2.0, Huawei developed Super C plus L-band technology, and compared with Super C, the spectrum increases by 83% and extends to 11 terahertz, which means it can support a maximum of 220 wavelengths with 50 gigahertz channel spacing, or 110 channels with 100 GHz channel spacing. With 800G per wavelength technology, the DC optics 2.0 solution can achieve a maximum of 88 terabits per second per fiber, bringing 40% more fiber saving. Traditional WDM DCI device O&M is CT-oriented and complex. Complicated fiber connections and more than 14 steps of manual configurations by professional engineers make the DCI deployment the most challenging and slowest part of data center expansion. Normally, it is a bottleneck for service provisioning. In version 1.0, DC Optics provides IT-oriented and automatic deployment. Due to the high integrated boards, the fiber connections between the boards in the traditional WDM DCI solution have become internal connections inside the board. So very few fiber connections are required. And one-click auto-commissioning functionality can enable IT engineers to finish the DCI deployment within 8 minutes. Further, with the digital optical network technology and intelligent algorithms, DCI is operated and maintained in a proactive way through the DC Optics 2.0 solution. As an additional benefit, network-level web GUI, which is the lightweight web NMS embedded inside the device, is updated to support Fiber Doctor, providing a built-in and fast fault diagnosis function. So what are exactly intelligent O&M functions in DC Optics 2.0? What benefits do they bring us? Let us check the details. The first one is fiber health prediction to enable a proactive O&M on fiber faults. According to statistics, fiber faults account for more than 68% of network faults. When the fiber capacity is greatly increased, we have to ensure that fiber is working well in the DCI system. If packet loss occurs due to optical fiber faults, the storage throughput will decrease greatly and the computing power cannot be utilized. Due to deployment modes and harsh environments, developing faults of the fiber account for more 20 to 50%. These slow-changing, sub-healthy fibers do not cause packet loss immediately, but will easily lead to an obstruction or even disruption of data transmission. In the past, maintenance is performed only after a fault occurs, or the users complain and the sub-healthy fiber cannot be identified in advance. But now, with Huawei's DC Optics 2.0 solution, this becomes a reality. Gradual degradation of fiber is predictable days or even weeks in advance, and the accuracy rate is 90%. The second one is co-bundling fiber cable detection to identify where the fibers are in the same cable route. Fibers are a dumb resource. For cables that have been laid over many years ago, it will be hard to identify the path because manual recordings of the path are prone to errors. So this function is helpful for protected DCI scenarios where working and protecting fibers should be in different routes, enabling that the protection really can work. All these innovations rely on Huawei's own strength in intelligent technology, which builds an all-around intelligent capability on NMS, IMS to NCE. More than 600,000 Huawei optical network devices are deployed in the world, which accumulates rich experience and data for machine learning. With various intelligent algorithms, Huawei developed, such as time series prediction and enhanced logic regression algorithm, the IMS to NCE predicts the risk of faults and specifies fault points in advance based on the changing trend of optical performance. Similarly, based on the embedded optical pulse reflection technology, IMS to NCE is able of making the intelligent analysis on various parameters generated by light transmission in fibers. Through comparison, it provides the function of co-bundling fiber cable detection. And the third one is accurate troubleshooting. On the DCI network, multiple alarms would be generated on a fault, As a result, a large number of alarms are generated on the network, but the root alarms cannot be identified. So many invalid work orders are dispatched. By using the alarm compression function, the NCE uses the hierarchical clustering algorithm to aggregate alarms generated by the same fault into a category based on alarm features, such as time characteristic, topology features, and service features, thereby reducing the number of alarms by more than 95%. In addition, the IMS NCE uses the supervised sample learning, for example, historical fault experience learning, and uses the neural network algorithm to find root alarms in 3 minutes. As the key product of the DC Optics 2.0 solution, Huawei OpticStrand's DC908 has ranked as a leader by Global Data, which is a well-known analyst firm. According to Global Data, DC908 is a leader in 5 key evaluation dimensions. After its release, this product was ranked leader for 2 consecutive times by Global Data. It's the only product from the 7 main vendors in the DCI field. As DCI evolves towards mesh networks, in order to ensure the visit efficiency and low latency, in most cases, one-hop direct mesh networking and optical switching with ROADMs is necessary. For traditional ROADM technology, one optical subrack is required in one direction, which occupies a large amount of space. With the full connections in all directions, the fiber connections between boards and racks are obviously complicated. Huawei developed the first all-optical cross-connect, OXC, in the industry. Huawei's OXC firstly introduces optical fiber printing technology to implement all-optical backplane and achieve 0 fiber patch cords. Besides that, the board on OXC integrates 5 boards into one to achieve one direction with only one OXC board. OXC greatly simplifies the configuration and fiber connections and can help customers save 90% space and 60% power consumption. With all these features, Huawei DC Optics provides one-blade benefits to the customers. So far, more than 350 customers from 65 countries have chosen Huawei DC Optics solution, which included customers coming from various industries, including OTT, ISP, finance, energy, government, and other large enterprises. Huawei's DC Optics 2.0 solution continuously provides intelligent and reliable DCI for global enterprises. Thank you for your attention.
Thanks, Maxime, for your presentation. As mentioned, Huawei DC Optics solution has been widely used in industry and brings about better DCI evolution. So let's hear from our customer, Mr. Roland Bersala, CTO of Philippines Converge, to introduce his experience with Huawei DC Optics solution.
As an innovative ICT service provider in the Philippines, Converge is actively exploring new businesses, such as IDC services. So far, we have already built or leased 9 data centers in Metro Manila. In addition to our own services, we also carry lots of internet and enterprise applications, including video, e-payment, online education, and telecommuting. These new services are based on AI, big data, and cloud computing, placing higher requirements on data center interconnect. In particular, the bandwidth demand on DCI has increased tenfold in just 2 years, and traditional DCI solutions could not keep up. When bandwidth, space, power consumption, and O&M fall below expectations, DCI must be upgraded. DCI is crucial to the computing capability of data centers. Ideally, WDM DCI should be future-proof for the next decade. Fortunately, we chose Huawei DC Optic solution, which consists of Optic Strands DC908 and iMaster NCE. The Huawei DC Optic solution adapts to multiple services and can deploy optical and electrical layers in one box. Thanks to the high integration design, the footprint is reduced by over 70%. It delivers bandwidth in core data centers that is 20 times higher, significantly reducing fiber cost. DC908 supports a maximum of 800 gigabits per wavelength and up to a maximum of 120 wavelengths. The largest single fiber capacity in the industry, perfect for Converge's long-term development plan. DCI is an important player in data center expansion. When you have slow DCI deployment, it holds back your expansion, resulting in delayed service provisioning. This poses a big problem, especially in a digital economy era that is highly competitive on fast service rollout. To overcome this problem, Huawei delivers automatic commissioning through DC908, slashing deployment time from days to just 8 minutes. This can be easily completed by our IT/IP engineers, which greatly improves our ability to respond to the market changes. When DCI becomes overwhelmed with traffic, O&M becomes the #1 priority. In response to this, Huawei DC Optics provides intelligent O&M for DCI fibers and devices. It offers fiber fault prediction, allowing us to identify whether optical fibers are sub-healthy several weeks in advance to avoid unnecessary losses. The system intelligently determines whether the working and protection fibers are on the same route or cable. This is useful in scenarios where fibers are leased to configure DCI protection, avoiding ineffective investment. Additionally, precise fault locating lets us filter out 95% of noisy alarms, helping us quickly locate root causes. These intelligent functions massively enhance O&M efficiency and the reliability of the entire DCI system. Converge is striving to advance the Philippines' digital economy, and our new strategy of providing reliable IDC services based on future-proof DCI technology is at the heart of this. By cooperating with Huawei, we have learned about Huawei's leadership in the DCI field. Through Huawei DC Optics 2.0 solution, we are confident and ensured that Converge will thrive more in this field to provide the Filipino market with the services they truly deserve.
Thank you, Ronald. In Huawei's data center network solution, AI-powered modularization and intelligence redefines the network architecture, power supply, temperature control, and O&M to build next-generation intelligent data centers. Mr. Winter Han, Director of the Data Center Facility Solution Marketing Support Department, will share his thoughts on green data center facilities. Let's welcome Mr. Han.
Hello everyone, my name is Winter Han from Global Marketing Support Department of Huawei Data Center Facility. Today it's my pleasure to talk about green data center facilities embrace carbon neutrality. Carbon neutrality is a very hot and also important topic for the whole international society. with the efforts of the international society. Most nations have agreed the Paris Agreement, and also they have defined the Paris Agreement roadmap. Every 5 years, they will make the global count and update for the NDCs. And in this way, they try to achieve the zero emissions in the year of 2050. For the carbon neutrality, and also is a very important mission for the other nations and countries. For example, in China, the leaders have declared that we will try to get the carbon neutrality by the year of 2060. Carbon neutrality is our common goal for every people, every country, every economic entities. But if you look at the power consumption and also carbon emissions for the data center, you will see that data center is a very big power consumers. And if you look at the PUE of the data centers, the average PUE of data centers, global data centers, is around 1.67. It means that more than 67% of the energies has been consumed. If you break down the power consumption inside a data center, if you look at the 10-year TCO of the data center, more than 60% of the cost is from the electricity cost. Huawei will provide the Fusion DC, the next generation data center facility solution, to realize the green data center. And we have the full modular and prefabricated solution to reduce the time to the market. The traditional time to the market of the data center will be more than 20 months. With Huawei Fusion DC solution, we will reduce the time to the market to 6 months. This will realize the zero weight for the rollout. Secondly, we use the high efficiency indirect evaporative cooling solution to realize the high efficiency of the cooling part. Meanwhile, we have used artificial intelligence technology to enable the high efficiency of the cooling part. We realize the energy saving for the data center. And according to our calculation and also the practice, we can reduce the power consumption by 17% of the data center in Beijing. In this way, we try to achieve the zero waste of energy. Third one, we use artificial intelligence to the data center operation and the maintenance part, and also to improve the reliability of the facility. For example, we provide the intelligent power pod, which can have the predictive maintenance. And this can achieve a high availability and reliability of the power system and the data center. In this way, we can ensure that zero service interruption for the data operation and maintenance. The last one is the operation and maintenance efficiency. With the AI, the artificial intelligence, we can enable the maintenance efficiency to be improved by 35%, and also improve the resource utilization by 20%. This is a full modular and prefabricated data center solution. We call it a Fusion module. We use the Lego style constructions. As you can see the video, that this data center can be built within 6 months with 1,000 IT racks. Also, we can realize the 1 layer, 1 DC to achieve the scalable layout and also the scale up vertically. In this way, we can reduce the initial invest by 40%. If we can use this solution, the total return of the investment can be shortened by 2 years. With the prefabrication of the solution, we can reduce the construction waste by 80%. Meanwhile, compared with the traditional brick and mortar data center construction mode, there's less noise emission during the construction. And also, if you look at the end of the lifetime of the data center, the recycling rate of the material of the data center can be more than 80%, but the traditional one can be only less than 50%. As you know that the cooling part is a big consumer of the data center besides the IT power consumption. How to reduce the power consumption of cooling part is very important. And we use 3 approaches to reduce the power consumption of cooling part. First one that we try to place the cooling capacity as close as to the heat dissipation. It means that we use a close coupling and air containment for better efficiency of the cooling part. Another approach, we will try our best to use as much as possible of the natural cooling instead of the mechanical cooling to reduce the power consumption of the cooling part. For example, we use the indirect evaporative solution to replace the traditional vapor compressor refrigerator solution. The third approach that we have introduced the AI technology to make the whole cooling system working as the optimum conditions. In this way, we can achieve the system level optimum efficiency of the whole data center. If you look at some detailed technologies, we can cool down the equipment, especially for the chipsets and also the servers inside the data centers. We have some technologies. For example, the supercooling. We use the board level vacuum chamber phase changer radiator to cool down the chipset. In this way, the heat dissipation efficiency can be improved by 20%. We use the mixed flow fans and to take place the traditional fans. In this way, we can improve the air volume by 3 times. Meanwhile, the power consumption can be reduced by 50%. With this system level and also component level technologies, we can realize the high efficiency heat dissipation on the board level and also the chassis level. This is the iCooling solution, as I have introduced in the previous slides. iCooling solution uses artificial intelligence to make the automatic adjustment of the cooling system to achieve the optimum cooling efficiency. Compared with the traditional manual operation and adjustment, the AI technology, the iCooling solution, can get more parameters collected, more data, and in this way we can optimize the cooling efficiency in a short time, and also can adjust more parameters, and to make the best usage of the cooling solution. Now I will introduce a new approach of the cooling equipment. We call it indirect evaporative solution. And this will, in most areas, this solution can replace the traditional chilled water cooling solution. Compared with the chilled water cooling solution, the system has been simplified, and also the cooling efficiency has been improved. The annual PUE can be reduced from 1.28 to 1.24. By this, the PUE can be reduced by more than 12%. If you convert the PUE into the energy consumption and also electricity phase, we can save around $2.7 million for the 10 years life cycle. Meanwhile, with this solution, we can reduce the water consumption as well. If you see that, with this solution, the water consumption can be reduced by 18%. Another is for the power part. Power part is also a bigger power consumption. If you look at the diagram on the top, you can see that if we want 100 watt server load get powered, from the source, you need at least more than 860 watts core power. If you divide this, you can see how low the efficiency is. A lot of power has been wasted during the power conversion. So improve the power conversion efficiency is also important. From Huawei UPS, this is a very important power supply system in the data center, we have delivered the 100 kilowatt amperes power modules with only 3U height, the most high density, and also with the efficiency more than 97%, highest efficiency for the power system to realize the energy saving. With the latest solution, our Huawei UPS solution, our intelligent online mode can achieve the efficiency is more than 99% compared to the double conversion efficiency. So 1% of the efficiency improvement can bring more than 960,000 US dollar savings if you use the data center is around 8 megawatts IT load. So this is also a big saving from power side. If we look at the power supply evolution, we will see that shorten the power conversion paths and also reduce the power conversion steps. This will dramatically improve the whole power chain's efficiency. If you look at the future, I think from the power source, for example, 10 kilowatts AC power will be converted to the DC power by 2 conversion steps to power the IT load. In this way, we can further improve the efficiency of the power chain. The last one is about the management and operation system for the data centers. And we have, the NetEco C-Silent system. This is the data center infrastructure management. With this system, we can realize the digitalization and the visibility of the data center. We can use the artificial intelligence technology to enable the PUE optimization to improve the maintenance efficiency by 35% and also improve the resource usage by 20%. You see the videos I show that we can use a robot to do the routine check and also maintenance to replace about 80% of the manual operation and the maintenance. With this Huawei solution, we have a lot of successful practice. For example, Huawei has been working with China Mobile to use artificial intelligence to optimize the PUE in the Ningxia province from 1.6 to 1.36. We can save around $0.4 million every year for the electricity fees. Another successful practice is that we have built a data center in Qinghai. The whole power of the data center is from the renewable energies, is powered from the solar farm. We also have some practice for the artificial intelligence implementation and practice in Huawei own cloud data center. For example, in the Langfang, we have applied the air cooling solution for the legacy old chilled water data centers. The PUE has been reduced from 1.42 to 1.26. The energy consumption cost has been saved around $1.5 million a year. Also in Wulan Cap, in the Mongolia, the north part of China, we have used the indirect evaporative cooling solution and to cool down the cloud data center. The PUE is lower, is around 1.15, and also the electricity cost can be reduced 12% compared with the traditional chilled water system. We think that with our contribution and innovative solution, we can realize a green data center and also take the responsibility of the carbon neutrality. This is my today's presentation. Thank you very much.
Thank you, Mr. Han. As we come to the end of this session, let me thank you for joining us at Huawei Industrial Digital Transformation Conference 2021. If you'd like to rewatch anything you've just seen, please visit e.huawei.com, and to learn more, contact your Huawei representative.